Hi, I'm Bonnie Martin on behalf of the Northern Nevada Science Coalition, and this is the first in a series of interviews with Reno scientists. We hope that you find it interesting and informative and fun. Tonight we're here with Hans Moosmuller, a physicist with the Desert Research Institute. Hans, tell me a little bit about, in terms that I as a layperson can understand, your science, your particular area of physics, and what importance it might have for us, why we should be interested.
Well, at the Desert Research Institute, I work in the Division of Atmospheric Sciences, which is kind of funny because I've never taken a single atmospheric science class in all my life. And my background is in physics, mostly laser spectroscopy and optics, and I try to apply that to the atmosphere. And I work mostly in the field of atmospheric aerosols, which are small particles suspended in air. With small, I mean about a thousandth of a millimeter or smaller. And why do we care about these particles? There are several reasons. These particles have fairly severe health effects in pollution events, have effects on the respiratory and the cardiovascular system of humans. We see increased hospital admissions during pollution events and increased death rates. So the EPA regulates these particles. And they also have effects on the global climate, on climate change. And
a hot topic these days.
And that is because they scatter and absorb light in the atmosphere.
So how do you measure these aerosols in the atmosphere? What kind of setup do you have to have?
Well, the traditional way of measuring them is to just collect them on a filter. You suck air through a filter, and then you weigh the filter before and after, and as you know how much air you drew through that filter, you can get a mass concentration of the aerosol, how much aerosol mass is there per volume. And so most of our regulations are written in mass concentration, and there's no big reason that's important because it's important for health effects. It's just what people could measure. That's why we regulate it that way. And now the more modern instruments often use optical or other properties of the aerosols to get continuous measurements.
Do you work with students?
Yes, I do. I'm in the graduate faculty in the physics department and the chemical physics program and the atmospheric science program. And I have students, graduate students in these programs. And I also have frequently undergraduate students in our laboratory and sometimes high school students from the Gifted and Talented program.
Oh, wonderful.
The Washoe County School program. And I really enjoy working with students because as you get older, your mind gets kind of in a rut. 20 years ago you decided, oh, you could never do this because out of these reasons, and the reasons might have changed, but you don't revisit your thought process. You just remember the conclusion. And students don't have all this baggage. They think something can be done, although you perfectly well know it can't be done. And sometimes you're wrong, and students do it.
And so
it's very refreshing, and it keeps you thinking and consider things from a different perspective, and a more modern perspective.
Great. Do you have advice for students who are considering science as a career? Things that you would suggest they explore or do?
Well, I think one advice I mentioned earlier, that science, if you're a working scientist, is very different from the science you're presented with in school. And the other advice would be that science does not exist in a vacuum anymore. There are very few gentlemen scientists who just don't have to live off the science and just do it for fun and games. So science is really part of society, and you need to communicate your ideas for research and your research results. So one thing which becomes more and more important are these communication skills. So taking your English classes serious, or whatever language you speak, is very useful, because when you have a scientific idea and want to get money to do the research, you have to write a proposal, and people will read it, and how well you organize your thoughts and how well you write it is a big part of getting funded. And the same thing when you get your research done, you write reports, you write publications and all that. So writing and communicating, going to conferences and talking to people is very important. It's virtually impossible to be a scientist and just do science and not communicate these things, otherwise the science wouldn't have any impact.
So language and communication skills are very important as
Yes.
well. Very interesting. Thank you, Hans, very much for spending time with us, and we look forward to seeing more of your work on the web.
Well, it's been a pleasure talking to you.
Thank you.